My office hours, Monday morning from 11 to 12:30 and Thursday afternoon. But these are not only the office hours that I can help you. You can email me so that we can do some other extra availability. And if you want to contact me for faster response, I want you to use text. This is my cell number. Text me first. Text me, okay? This is my office number. Office, only if I am in my office. We have two websites running. So Blackboard, so you can do Blackboard as you wish. At the same time, we also building some materials on this is our own cybersecurity web server, which is sitesecure.org. So if you want, let me see if I can. I will introduce you to this for you. This website has very, very useful information. This is sitesecure.org. It's our Mercy College of Cybersecurity. Some testimonials available. So we will have more. I think I have some more here. Oh, I have to change this. Summer is over. So 520, this is 520 that we used for last year. I'm not sure we're going to use the same data sets, but this is that. Right. For your fun, we have a cybersecurity competition 2017. If you click here, then you can see some progress. So as you see, this is the team where James is involved. They have some of the materials like this. They capture radio signals sending from each tire to the control units. And the team sniffs signals to find out. I do not know how much they detected the information. So some of their video clips here also. Right. So if you have time, then you can take a look at them. Right? And this is another team. Okay. So let's go back. This is our extra website in addition to Blackboard. So everyone here has Blackboard access, right? Fred, do you have? Yes. Have you been in there? Yes. Have you looked at, have you read the syllabus that I posted? And I posted it. So you can see, for example, the best way that you can access the mercy.blackboard.com. I wish I can let them know how redirect to this URL from, for example, blackboard.mercy.edu. It's a simple code, right? Simple HTML code. But okay, for this course, Web 520 DFA and 520 DLA. So for this, they are the same course. If you click 520, then there's a syllabus. The exact same syllabus can be found, right? So if you click this, then that is the same as this, right? Okay. And if you click course material, as I said here, all class materials are found within this folder. So if you click here, then you can see some of the course materials. Here, discussion forum, mainly required from online students. So you do not need to, if you want to, you can do, right? But it's not required in your case. We have also the first course material, hands out. We'll cover this a little later. This is Blackboard. So we have a Blackboard access and scysecure.org access. Depending upon the characteristics of the materials and size of the materials, sometimes I posted Blackboard, sometimes I posted scysecure.org. Then some students may be saying that, oh, I am so confused. What should I do? The best way is that you need to come both website all the time. But if you come to Blackboard, Blackboard is more complete set. Okay? If I post something on scysecure.org, then I guide it from your Blackboard. So if you do not have time, then you need to come to Blackboard. Blackboard is the entry point, and Blackboard has the complete hands-out and course materials. Okay, if it is not there, then I points out some there, so you do not miss as far as you come to Blackboard. Course descriptions, I wanted to read, but the first slide that I prepared for tonight covers a little bit why we need to do data mining, where data mining terminology comes from, and how data mining is relevant to cyber security. And also a list of the research topics. Part of the requirements of this class is a research, right? Semester project. I described that on this slide, but basically there are two ways that you can accomplish. One extreme end is that you just read a few research papers and summarize them and compare and contrast and write another paper review. That is a possible project outcome. Another extreme end is that you can develop some of the small tool that prototype or implement the concepts, algorithms that we will learn in this class. Okay? That is another. You can mix them. Those two extreme ends. Textbook, we do not have textbooks, but those who need some materials to read continually, the first reference is very, very good. This, okay. So, Jae-Wei Han, he's also very, very famous data mining researcher. Before he joined Urbana-Champaign, he was in Canada, Regina University, something like that, in west coast of Canada. Techniques that we are learning in this class are found from some of the research papers, so that we can we'll cover that. Meeting time for this class, the face-to-face meeting, so Wednesday, 6:15, here in this lab. If I ask you to do some of the coding, by the way, I will ask you some of the coding. Okay, Python is the language that we are using. Of course, I'm going to give you detailed lecture, and I ask you to sometimes finish some of the algorithm if we start in the classroom in Python, or sometimes I may ask you to do using R. Okay, R. It's another statistical tool. It's not really purely data mining language, but it has some good and powerful statistical implementation. So we're going to use that also. Grading. Homework assignment, 35%. Exam, 35%. Equally the same, 35%, okay? And then group project, 25%. Participation, 5%. Major participation is your attendance in class, okay? If you do not attend, then that affects your participation points. Grade, over 95, A, and each 5 points difference, so you will have A minus, B plus, B minus. Since this is a graduate course, you may not have the grade that I highlighted here. If you receive a C, then there's almost similar to F in graduate. Okay? What does that mean? You will have either A or B. Group projects. This is a group. Okay. By the way, we do not have. It's not a big group, so maybe 2 or 3 students, or 4, or individual, whichever convenient to you. Fine. Okay. You can, when you do a group project, I want you to think two aspects: technology and application. Okay. Technology of data mining, then you can think of, for example, statistical analysis, rule mining, fraud detection, classification, clustering, and things like that. Okay, there's some algorithmic development or implementation. If we do not develop by tweaking existing algorithms to improve some, then you may simply implement already known algorithm. Okay. So algorithms that we learn in this class. We do not learn all the algorithms available. Why? Because it has been almost 30 years after the term data mining was toasted. So a lot of research papers available. We do not cover all of those. Technically impossible, right? But I'm going to do a little bit of those. Classification and clustering, those two major the algorithms. So, using these algorithms, algorithmic development, you can pick some application so that if that is a short message application, then you can do monitoring suspicious discussion in short messaging. Okay? Or e-commerce, then price negotiator for e-commerce. Some behavior aspects so that you can predict some user behavior. This is a very, very interesting topic also, right? Those who like football game, for example, then you can consider the players that when they receive, although they do not receive, some offensive player or defensive players, the position where the player is, you can predict his next movement, right? So that your program can also predict the same way that you do. Okay, your knowledge can be implemented in some of the programs. I'm not sure there's a similar to fishy behaviors, so that if you some of the fishes, so that you can drop behind, or I don't know.
Every analogy is going to involve fishing this whole semester, guys. I'm giving you the heads up.
So he's going to bring one day
It's
fishes
true,
here.
though. It's true. No, you're right. But what you're saying is right, though. They do.
So you understand the fish's
they
behavior,
have,
right?
They have like statistical things like about like they actually have a device that you attach to it that gives you like statistics and certain. I'm not sure what information, but it's out there. It's like Kickstarter. You know, it's being developed, but I've seen it.
Can you develop some software to make it more intelligent?
It's true, right.
Crime rate prediction, for example. Okay. each city has a different rate. So by looking at the cities surrounding, what is the prediction? Something.
You know what this thing is actually? It's like a Fitbit, like like a watch, but it's for your fishing rod. And I guess that it could predict.
Okay.
That's what it is. I'm telling you, it's out there, right? And I think that it could, like you're saying, it could be used to predict, like, because it says the weather and all those things, and like the pressure, and, barometer, all that stuff. And I think that could be used to predict something, right?
Right.
I mean, where they
So
go.
it can tell you that also at the time windows which you could highly catch.
Yeah.
Another time window less likely catch.
Yeah.
Right. By using all the data, environmental data or some sensor data or human heuristics. So by combining all of those, you can predict some. Cancer prediction, same thing, right? Family history, many cases that is the most important to predict cancers. Is that really true? We do not know yet, right? Our cancer history is only maybe, it's not really century long history. With that amount of data, it's not really convincing. By using more and more data to be associated, therefore you may have more reliable conclusion. As you include more data, therefore you may very nicely think of big data, right? Data mining is not just from small data because of many reasons. As I explained right now, if you use more data to be considered, then more concrete results that you can have or predict. Therefore, hey, I need more data, more data, more data. I need more historical data. I need more related data. Therefore, it ends up with big data. Although there are a lot of missing data. As far as we have big data, then we have to take care of missing data. Okay. So I want to read many of these. For example, web mining, web server. Web server has the visitors, right? Visitors. If you build your own web server using some of those scripting languages, not just the HTML language, but CSS or PHP, a little more programmable languages to implement your web server, then you can collect the user information. Whenever user access, click, then you can gather the user information and save it. And then some of the mining from user data. It's not the user data that user enter, but user data that your web server extracts. Okay, so that is possible. Reports of your project result, you have to make a title page. On the title page, title and the member job distribution in a table form or in any form. I want you to describe, hey, I have been contributing this, and my friend did another part. Okay, so job descriptions needs to be specified in that way. Grading is not really equally the same among team members. It's not really critically different. For example, a project, oh, it's so nice, very good. Still, there's a little bit difference if their contribution is not similar. Okay, just
we did last semester. I think you were showing us a code, Python code that had it was like URLs. You made like a code that was like similar to this, where it searched for URLs and it like it extracted which ones were like it was something for the Mercy website. I think it was. I'm not sure. Maybe we'll end up doing.
Well, anyone that if you enter URL starts from. You graduated, right?
Yeah. He's like, you graduated, didn't you? And we'd be like, so what, I graduated, and come back. So we had to come around and bother him.
Access to sitesecure.org, like with credentials, or just like he's going to upload files there? So there's no like SSH or anything? I feel like Mercy never really locked out that stuff.
Afternoon, some afternoons. I have some spare time. Okay. So in your writing, start with the introduction. In the introduction section, you usually, when you write a paper, okay, you're not writing novels, right? You're not writing simple like essay, anything that you write that is technical writing, right? In any technical writing, because that it has some deep in technology, no one can understand easily although they have some background, although they have some interest, so that you have to start from very, very high and broad level, which means in top-down approach, you have to bring your audience to a deeper and deeper to the certain level where you want to describe your work. Okay? For example, if you are interested in some data mining from intrusive attacks, login files, okay, to your platform. So each different platforms, right? If there is a Linux server, then you have to describe something about Linux server. So Linux server is different from Windows server, which is different from Windows client, laptop, workstation, right? You have to explain little detail, not really quite a deeper level, so that the reader can, reader should not lose interest. Okay, you need to bring them a little deeper. Okay, something about platform and something about attack, right? So types of attack. If it comes in a Linux server, then how do they attack? Okay. For example, if it is a server, then it has IP address, and also from your server has multiple application programs installed up and running, and each application is passing out and coming back through a specific designated port, right? So each application uses a specific port number. If it is not, then we call that USB, right? That's universally used socket, right? This is a universal port. If it's not universal port, then each application program has its own specific port. So you need to describe, somebody wants to intrude into, for example, MySQL. Then MySQL is blocked, but one specific port. Through that port, MySQL is communicating with the outside. Okay, so attack point to that MySQL is again through that port. So your program needs to see, which port is open, which port is enabled, which port is disabled, and things like that, right? So that's the intrusion pattern. So once attacker comes in the system, then your host program needs to identify which IP from which that attacker comes from, so they save it, and user ID save, and everything needs to be saved. That's a logging file, right? So from that log files, now you need to do some, you have to apply data mining tools. All right, so introduction should be top down, right? Introduction section should not have any technology intensive description. You can introduce some jargon, some terminologies, but not in detail. Problem description. Again, in this problem description, it should be technical description. Any technology used in this description is not really common language, then you have to explain that language here in this introduction. So you have to explain everything that you use in your problem description, so that readers do not have any difficulties to understand the problem that you want to solve. And then related work. The problem that you describe here is not brand new. Very rare case, the problem that you are working on is a brand new and very unique problem. But I've never seen such problems dealt with by students, right? Even PhD students do not have that the first generation problem. If it is, then that is very, very good research. Related work. So what it means is that the problem that you want to solve, or not really solve, problem that you want to improve or resolve to a certain extent, the same work, similar work, have been done already. So you need to describe, hey, this researcher accomplished something in this direction, in another direction, and another improves a little bit, in another tweaked a little bit, in another applied that into problem number 1, another problem number 2. So various different contributions have been made that needs to be described in this related work. Although some work have been done successfully, still there is some weakness. Still there is some problems unsolved, right? Not all problems solved. A lot of problems unsolved. Okay? So you can pick unsolved problem, or you can pick partially solved problem, not yet, so that you can move that problem one step further. Only one step further. Do not try to make a breakthrough. Only one step, little bit, tiny little bit advancement. That is still worth. Many cases worth for your PhD degree. For master's degree, you don't need to do something new. If you make something new, then that is great. You can do, that is their implementation. This is my implementation. Of course, that is your implementation, right? Because that is what you have been doing. So the companies may buy you because of your effort proved in that way. Detailed work. So in this approach section, you can do broad although you have done a big amount of work, you don't need to say that all detail. You can say, hey, I've been doing this in a couple of paragraphs, and then you can, in the separate section, you can describe in great detail. So in this detailed work, some guys may not understand, But the guys, up to this point, our approach, they know what you are doing, so that they respect your work. And finally, conclusion. Conclusion is also very, very important. You have to conclude your work. Without conclusion, your work is still in progress or incomplete. Okay? So detailed work. This is more than 50% of your work, but not many audience are interested in. Not many audiences can understand. So this is your work. This is yours. You are the only one familiar with. You are the only one proud of. Right? So the other should be written very nicely up to your approach and also conclusion, except this part. This part is your work, but all others you have to describe in more understandable way. Okay. Any question about your writing and research? That's 25%, right? And homework assignments, 35% because I'm going to give you multiple homework assignments. So as you follow by completing homework assignments, then you will do a group project very easily. So altogether, this group project and homework assignments, it covers 60%. Right? So weekly assignments, weekly lecture is very, very important. As far as you follow weekly, I don't see any problem. So all others, I want you to read. And this is course outline. Today we'll do introduction, and then logical representation. Okay. And then third week, tech night. In the third week, we will look at Python. Okay. So maybe next week we start. I'll let you know. Today, probably I included it, right? But you need to, probably not, right? So you need to download something to get ready for you to build a proper lab environment on your laptop. Actually, two programs, right? Python and R. Python and R. We'll do a statistical analysis. And fifth and sixth week, this is association rule mining. And another tech nights, that we will deal with R. And after that, classification 2 weeks and clustering 2 weeks. Start from basic concept to advanced concept for each, okay, classification and clustering. And then we have another 10 nights, so a little more advanced topics. And then 13 week, project week. So I'll give you 1 week fully for you to, this is a group, on your own, do some work. And then following, we have a final week, final exam, that is in class. I'm not sure, in class or because we have online students. So altogether, maybe online exam. I didn't decide yet, okay? And then final week, there's a project presentation. Project presentation, okay? You have also freedom for this project presentation. If you have some issue, then you do not need to come, but you have to submit your video presentation. Video presentation should be available for anyone to access. Okay, so that is your presentation, or you can come here so that you can do in front of me. This is a syllabus. This is the plan that we work together for next 15 weeks. Around this time that we finish up, then I think that is very warm spring or early summer. Okay. Question? If you do not, then let's take a break. Typical data mining was successful if we use statistical approach, probabilistic approach, if we use something from databases. So we have fixed set of data and robust theory in statistics and probabilities. But now the situation is not moving based upon the fixed set of data. Data may be created, generated very dynamically. So previously unseen data now available, right? Who knows ICBM, SB, what is it? ICBM, that is intercontinental. Javier, you understand that, right? And the other one is submarine, SM. Some missile launched from submarine it's called SM something, right? I don't know. But something like that. Never known before, right? But now everybody understands some threats from my neighbor country, from some bad guy. But anyway, so data mining is an algorithmic approach, which means for given set of data, then we may expect always the same conclusion. There's an algorithmic approach, which is not really practical in many situations. Therefore, machine learning is another hot topic. So that machine learning is employed in data mining. So with the limited data sets, and then we can do some forecast in the way that we forecast one step earlier. If we forecast very nicely 1 minute ago, then why not we can forecast also 1 minute after? How do you know that we forecasted accurately 1 minute ago? If we train it, right? We have data set here. We know this data set, current data set. 1 minute ago, we have also data sets of the 1 minute ago. How this data set evolves, therefore we have the current data sets. So we train them, train that evolution. That evolution, your program therefore trained with these data sets. 1 minute later, then there will be another data set. That trained is not only 1 minute, 2 minutes ago, therefore we have a 1 minute ago data, and 3 minutes ago, from 3 minutes ago data sets, therefore we have 2 minutes ago data sets. So repetitively many evolution steps are trained, then why not one step further? Because we already proven record previous 100 steps of a successful evolution, then next one step is not really dramatically different, right? That is a technique that we are going to work. Another technique is that in human genetics, mutation, although we have that procedural proven record of evolution, at some point it's not going to work. It is a mutation, right? So another algorithm is really hot topic, which is called the genetic algorithm, right? Those two algorithms are the algorithm that we need to do to cope with the future unforeseen threats. So threats that we may have right now may not be threats in the future because they're already known, which means threats is really dangerous because the threats are not expected. If you have well-trained programs, the way that every time you have new threats, your program understands how to mitigate. In the same way, then, in the future, your program mitigates. So a little bit of manipulations possible. Okay? That is a deep learning approach. Okay. So we have to do, we already talked about this, right? We meet Wednesdays, and course materials are all available Blackboard and sciencesecure.org. Okay, what is why data mining? Data, the amount of data grows. There's no shrinking. Data generates more and more. Automatically, right? Now automatically. Many cases of sensor technologies, each sensor generates sensor data. A sensor data is generated every millisecond. How many sensors do we have? We have billions of sensors. Then per millisecond, how many data do we have? Wow. That's big data. Where such sensors are deployed? Everywhere. hospitals, down the road streets, city, residential areas, on the ground, up in the air, submarine, right, under the sea. So, data generates. Our concern is not data itself, right? We want to know what are all data about. I want to see, what is it? The answer to that question is data mining, right? Data comes in so much, somebody says, what are they? You can say, oh, that is some signals from 4 tires of my car. Quickly, right? Simply. And one signal that comes from my another car running side by side. Data mining history, before 1600, empirical science, so all throughout all. Computational science, data science, and in 2002, Jim Gray and Alex Zelle, the worldwide telescope on archetype of online science, communications of ACM. So 2002, I think that may be, 2 years after Jim Gray wrote that article, he was missing in the ocean, Pacific Ocean. Jim Gray is ACM Touring Award. Touring is the person who, what's that? Touring. A couple of years, there's a movie, right? Movie called. There's a touring cryptography movies. I forgot the title.
Submarine? Is that a submarine?
No. It's cybersecurity. Computer science. This is a Tory. His name is Tory. I think he's in England. Yeah, cryptography. But anyway, that is a guy. Jim Gray. 1960s, 70s. Okay, database evolution. Till 1960s, we have simply file systems. 70s, we have relational data models from 1970s. Although relational data model invented in 1970s, not widely used. It became so popular in many industries since 1980s. Okay. So relational database management systems deployed or acquired by big companies, and they store their data on that DBMS. Therefore, secure. Many cases. Unless otherwise, vulnerable. Therefore, many retail stores save the customer data in plain text file, which means it can be compromised. Right? Examples of such stores is Home Depot, Target, some of the companies. They are very silly, right? They stores, they're selling items on their database, but they didn't care about the customers' data. Customers' data equally or sometimes more important than their selling products. So it should be saved. So a lot of data. 2000s, we have streaming data and data mining and web technologies integrated with the database. So we are ready for data mining. So what is data mining? Data mining is an extraction of interesting, non-trivial, implicit, previously unknown, and potentially useful patterns or knowledge from huge amount of data. That is data mining. Okay, that's the utmost definition of data mining. Alternative names for data mining is knowledge discovery or knowledge mining in database, so-called KDD. So we have DM for data mining, or KDD for data discovery. I mean, knowledge discovery from databases. Very similar. KDD process. From the raw data, this is raw data, right? From the raw data. Sometimes there is only data in plain text files, or that may be in a table in a database. So we have columns and rows. So data needs to be extracted from database language. If this is a plain text, then data can be loaded in your program file, for example, Python. Then Python opens a file and read each line. That is a Python. SQL language, so we can do here Python, right? Simply, I can give you all executable code. So I want you to understand what each line means. Definitely, of course, I explain it, but that is my explanation. You have to also explain on your own. In that way, that is your language, not my language. If that comes from your database, it is called the SQL. Right? Structured query language. This is a very high-level language. That high-level language is understood by DBMS only. That language is not understood by your laptop computer itself. That language can be understood by your MySQL or Oracle or SQL Server. Okay, only can be meaningful as far as you have that engine. Okay. Internally, this SQL, because this is a very high-level language, your database engine convert this SQL to another language like Python or C. Right? This is internal process. SQL is high-level language only because you do not have to worry about that conversion process. You do not have to worry about running that Python language. You simply worry about very high-level concept, SQL. So from this, you do some, you build the data warehouse, task-relevant data, and finally you have some pattern. Okay? You mine the pattern, then pattern needs to be evaluated, saying that, oh, this pattern is useful. This pattern is previously unknown. This pattern is meaningful. This pattern may occur every 10 seconds. This pattern may occur once in a lifetime. Which pattern is good? Pattern occurs once in a lifetime, or pattern occurs every 10 seconds? Every 10 seconds, then you can use it, right? What is the point of data mining? Pattern needs to be used. Okay? If you mine some pattern, therefore you can deploy that pattern to protect your system for cybersecurity. Or you can use that pattern to promote your business model. So make more profits. Things like that. So evaluation. Between this, from here to there, so a lot of process is available. Some of your work may reduce some of the process steps, or some of your work may need more steps. So each implementation, each research outcomes may structure different products, right? So this is very general process of data mining. From raw data, I want to get some patterns. Let me repeat that pattern. The pattern is very, very historic pattern. Whoever teaches data mining may not forget to use this following examples. Okay, I'm going to use that example again. The grocery store, for example. We call that basket example. When you go to the grocery store, you can pick up a basket to hold the items that you want to buy, right? Nowadays, we have a cart, right? Cart or basket, they are the same, right? So in your basket, you have different kinds of, different quantity, different kinds of items contained. And cashiers collect all of those. And then the grocery store has a database, columns and rows. So one basket. Teller 1 at time T1, because there is a customer, that customer purchased the item 1, 2, 3, 4. and another basket, item 1, 2, another basket, item 2, 3, whatever, right? All different combinations. So data mining tools applied to a specific grocery markets, and the patterns that they extracted from the grocery market transaction database is those who pick up beers can pick up diapers 90% on Friday afternoon. If that grocery store is in suburban area. So what happens is that in the suburban areas, usually young couples live because property, the home price is lower than hot areas, right? So young couples live in the suburban areas. So Friday afternoon, after work, on their way home, they stop by the grocery stores, and they got a call from wife, and hey, bring diapers. And this guy says, oh, I want to drink so beer and diapers together. In that particular grocery stores, that association, diaper and beer together, occurs so often. 90% of the baskets have the pairs of beer and diaper. That is the pattern, right? That pattern, if that pattern occurs and applied more often, then that is a very, very useful pattern. Why that is useful pattern? For the grocery stores, they want to stock together. Diaper, one column, next to that column, beer. That doesn't make sense to our normal reasoning, right? The stock manager never thought that they should be together. Therefore, customers can pick one very quickly another. Not only that, they never forget. When they pick beer, next to that aisle, oh, we have diaper. Oh, I should not forget. Right? Marketing, right? Sells more because they can be stuck together. Those useful patterns. Are there be such patterns available in another applications? Why not, right? There's all such cases available. That data mining algorithm is specifically called association rule mining. What that means is that one item is associated with another item. Very, very highly likely. Whenever this item comes out, this item also together. That is association. That is widely used these days, right? If you buy some from Amazon, you pick one item, then in the near bottom, there says, you want to buy this also. Sometimes you know that, oh, I shouldn't forget this. It helps sometimes. But sometimes you have some impulse purchase because of that. You have some experience, right? When you buy Raspberry Pi, then they ask you, oh, you need to buy extra keyboard, extra mouse, HDMI cables, whatever, extra audio and mic speakers, right? There is a speaker jack, but you should have to plug in, therefore you can play music, although you are using Raspberry Pi. Raspberry Pi is a small. I have a Raspberry Pi there.
They usually offer you the SD card with the Raspberry and flash on it, I think. That's what they usually offer you.
Usually, right?
Yeah. that's
But
what
it's
they
not
usually
necessarily stick together.
offer.
That comes from association rule mining. Okay. Examples, web mining. So a lot of examples available, right? You can do web mining. You can apply that in business application. See here, on top you have decision making. Start from data source. All the raw data, web documents, files, papers, database systems. How can we get my highly profitable decisions starting from raw data, whole process, right? Not only this, some external documents also needs to be considered. So these days, we call that sentiment analysis. Sentiment analysis, which is text mining. Nothing but text mining. Not only atomic data that can fit in a cell of spreadsheets or database tables, but descriptive text, like textbook or newspaper or news, TV news or documentaries. So full descriptive narratives. So how can we pick some from that narratives? There's a sentimental analysis. Text mining. Okay. If you want to predict a stock price so that gain, when you purchase some stock for some companies, then there is a company data, right? That you can manipulate by your typical programming languages, because you have rows and data, which is atomic data. At the same time, company has a lot of publications. That is just text, right? Narratives. How can you use such narratives? So you need to develop another text mining, scanning text and see if there is some meaningful semantics, so that I can use that semantics to my decision making. By looking at data only, tomorrow I can make $10,000 if I purchase $100,000 of this stock. But there is some very, very hidden publications. It's not yet converted to the data that you can manipulate from your program, but there is just narratives or some newspaper. Without considering that narratives, your decision may be partial, or there may be a mistake. So that is very, very important.
It won't always be true, right? The narratives, like you're saying, it won't always be true.
Mm-hmm. It's very hard. It's not simple. It's not simple to manipulate data in database. Right? In text, should be very, very intelligent. Not just by picking keyword. Some keyword and some negatives, then the keyword keyword has negative impact. How can you use that negative impact? So in machine learning, similar to that, input data here, we have pattern information and knowledge. We have data mining. This is pre-process and post-process. Pre and post each. In the middle, data mining. Then we can see here data mining tools. We have a pattern discovery, association and correlation, classification, clustering, outlier analysis. Those are all the techniques of data mining. To make data mining more efficiently and more effectively, then you need to have proper pre-processing, which is data integration, normalization, feature selection, dimension reduction. What do you mean by dimension reduction? For example, this. Oh, I want to compare this and that. More specifically,
same format?
When we describe one object, factors to describe one object is really multi-dimension. Let's say we describe about students. What factors may be used to describe students more efficiently? First of all, name, date of birth, race, home address, telephone number, elementary school attended, middle school, high school, friends, best friends and enemy friends, best girlfriends, enemy girlfriends, all of this, parents, all to describe one object, multiple dimensional factors, multiple dimensional data should be used. Then, here's a question. How can I compare Jess from James? How can I compare Jess from James? We cannot compare like hundreds of different factors. We can compare simply, sorry about this, I'm not talking about racism, but a pretty critical example. Okay? White guy and Asian guy. Quick, right? I didn't compare, I didn't use their first name, last name, age, schools, they have attended, parents' information, and home address or their incomes. I didn't add. By using only one simple, that identify them very critically, right? So there is a dimension reduction. The way of reducing dimensions, we may have better, more efficient way of clustering or way of classification, for example. For that, let me give you one example. From our website of sciencesecure.org, here. This is my demo that I made. back here. Play.
Yeah, this is one of the demo for our cybersecurity competition participants.
Look at this. This is a camera. This is
this is
Arduino Uno.
controller and all processes
Not really.
installed. Right now, this camera is not really responding to my movement or anything like this. It doesn't,
This camera
because of training.
respond to some objects.
Chasing me. This guy is the target. This. If this occurred, then stops. If something else comes.
It doesn't respond to my finger points.
no big
It doesn't respond to my cell phone, but it responds to
this, then it responds
that. What does that mean?
like this.
Color. Color. Object has so many different data associated with it, right? The camera can identify only if we train. We have to train, right? Train color only, saying that, hey, you understand that this is red color. Follow this. Then it follows red color only. Like your doggies, right? If you train your doggies, it follows you only, right? How can you train your doggies? By feeding, right? Some cookies. Then your doggies always follows you. You have doggies?
If you feed a dog cookies, they'll die. There's no doctor.
I mean, for example, right? Yeah.
I know what you're getting at, though. Don't
Right.
worry, I know what you're
This is exactly the same way of training. Train, therefore respond that. When you train, we have to use only a specific reduced dimensional data. We cannot use that entire whole. Current machine learning and current artificial intelligence technology is not that intelligent. Still dummy. But when it comes to that example, it behaves very, very intelligently. See it? This camera looks like very, very intelligent, right? But in fact, that is dummy. It understands only red color. Okay.
Didn't I think, Vladimir Putin, didn't he say that the nation that leads in AI is the nation that's going to lead the future or something like that? I was just reading some article about that. About something with whoever has the first in AI.
Enron Tusk, right? The guy who Tesla, right? Tesla CEO. He's very, very skeptical aspects on artificial intelligence, right? You read that article, right? My son during summer told me compared to Enron and Zuckerberg, right? Zuckerberg has a very, very positive and optimistic, not optimistic, he has a good feeling on artificial intelligence, whereas Enron very skeptical. Okay, I think we have to finish up quickly. Medical data, so a lot of medical examples, right? As sensor technology evolves, internal medicine doctor, expert may not be useful anymore, right? You feel that, right? If you go to a doctor's clinic, your primary doctor, they don't do much. Only they do is the referral. They write referral letter so that you go. If you have a mental issue, then go to somewhere. And sensor technology now can do better than human decision about where to go if you have some sensors. So in the near future, internal medicine doctor will disappear. Right? Medical. How then, which programs, which applications needs to be developed? By using all data so that we have associations. Yeah, associations. This kind of symptoms, this kind of health data states, then possible disease will be XYZ in 90% accuracy, for example. Or in next 5 years, this kind of data may lead to another disease. So that we have a 5-year term, therefore now we treat some. That is a medical example. Multi-dimensional view of data mining. We talked about this already, right? Data to be mined, knowledge to be mined, techniques, applications. So this is also a good slide that you can do. You can pick up your research topic. You can pick, for example, I want to rely on database. I want to use a warehouse, data warehouse. I want to use a transactional data, stream data, and so on and so forth. I want to use a characterization, discrimination, association, classification, clustering, trend, deviation, outlier analysis. This is some technologies, algorithms, right? And then techniques that you use, an application, retail application, telecommunications, cybersecurity, banking, fraud analysis, all such things. So pick one from each categories, then you can say, I want to work on this. That is your research topic. All kinds of data available. Techniques. Those are major techniques discussed in data mining and knowledge discovery. What we are going to do, we are going to focus on association, classification, and clustering. Okay? Those three techniques are focused in this class. So semester project, along the way that we looked at. Proposal by September 27th, midnight, 10 points. Written reports, 30 points. Points is not necessarily this, because semester project is 25 points, right? I would say 25, forget about these points. But written reports is big. This should be 50%. Oral presentation maybe 30%. And proposal 20%. Okay? So you have to write proposal by that time. By reviewing this, today's slides, you may see, this is my interest. And pick, although you do not know yet all detailed technology, pick some, and then we can discuss more. Research topics, I listed, read them. For example, something about e-banking log system, financial status analysis using credit and score rating, or website evaluation using opinion mining, and something like that, and more and more. Stock market analysis and prediction, right? And customer behavior prediction using web UCG mining. A lot of those. I think this is it for today. Any question? Okay, then I'll see you next week.